Okay, here we go. 6.5. Ready? So which one are we on now? Are we on 6.6? Right, first one to be put on. SSS similarity theorem. So this is about similarity, not about congruence, right? We had congruences in chapter 4. We're talking about proportions and similarities. So if the sides are proportional, so if every side matches up and gives you the same scale factor is what it's saying, all right, then the triangles are similar. So if AB over DE, which looks to be the longest sides, is equal to BC over EF and CA over FD, then we would say that the triangles are similar to each other. So we're looking to make sure that the scale factors are the same. That the scale factors are the same. And so I'll give you a second to write this in. And this is the SSS. All right, so here's an example. I have triangle ABC, and I have two other triangles, DEF and GHI. So I'm going to label this one 1, I'm going to call this one 2, and this one 3. So I'm asking you which of the two triangles are similar to triangle ABC. So if I'm asking them to be similar, then what do we know about the sides? Same scale factor. So we're looking at the scale factor. This chapter is all about the scale factor, a comparison of the two sides. So let's say I wanted to do, let's compare 1 and 3. Triangles 1 and 3. How do I know which sides to match up? In other words, if I want to match AB, which is 12, and I'm looking at triangle 3, I have 8, 16, and 12. How do I know what side is going to match up with the one whose length is 12? How do I decide? Because there's only one that I can do. Claire? Okay, but we don't, so we have to find another way. So you're right, angles would help us if we did. What do you think, Bryn? So we got to look at our lengths, right? 12 is the middle length on one, so we're looking at the middle length on the other one. So which one is the middle length? 10. All right. This reduces down to, divide them both by 2, and we get 6 over 5. So that's what the scale factor should be. All right, so let's pick another set of sides. What other two sides should I pick to compare? I have to make sure that the scale factor is the same. All right, small one here, small one here. 8 over 8 reduces to 1 over 1. This implies what? If it's a 1-to-1, what does that imply? Congruence. This implies congruence, not similarity. So would we say that these two triangles are similar? No, because the scale factors aren't coming out to be the same. All right, so 1 and 3 don't work, so let's try 1 and 2. All right, pick two sides. Which two sides am I going to compare? Eight and 6. Oh, so you're doing small over small? 8 over 6, so that's a 4-to-3. Just make sure that you're always starting with that same triangle. All right, Jessica, give me another set. Well, we're doing 1 and 2, not 1 and 3. Oh, this? Okay, but then you're going small triangle to big triangle, and we went... Okay, so we're going to go 16 to 12, which reduces. All right, so far so good. But you've got to prove it 3 times to me. You can't assume that if 2 of the scale factors are the same, that the third would be the same too. And so we'll look at, what's the last one? 12 to 9, which gives me also 4 over 3. So the scale factors are all the same. Therefore, the triangle 1 and triangle 2 are similar. By the SSS similarity postulate. But now we're labeling with a theorem. We had AAA, now we have SSS. Uh-huh. Well, what we really should say is that, well, we're going to write our similarity thing. We're going to say triangle ABC is similar to, and now we got to get our letters right. All right, so what would the order of our letters be? If I go A, B, C, so medium, small, large, D, E, F, triangle, D, E, F, right. So get your order right. And this is called our similarity statement. Okay? All right, so now let's look at another problem. Triangle JKL is similar to triangle MNO. Why am I giving you this? Why do I give you that statement? What's that supposed to help you figure out? Artie? Okay, so that means JK will be compared to MN. And that, because they're similar, KL will be compared to NO, and JL will be compared to MO. It kind of helps you to write all that down. All right, so let's take a look. JK is 12. MN is, I'm going to write that as 3x minus 6 instead of 3 times x minus 2. Okay. KL is x plus 6. NO is 21. JL is 20. MO is 30. So if they're similar, we have to have a scale factor. What's our scale factor going to be? What is it? 2 over 3. All right, it's 2 over 3. So we know scale factor is 2/3. That means when I set all of these sides over each other in the right order, they should be congruent to 2/3, right? All right, so how does that help me find x? What would I do to figure out what x is? Andrea? Two over 3. Or what else could I do? What other proportion could I set up? What else? Annie? What's the last one I could set up? Claire? But that doesn't help me solve for x. All right. Either of these should give me the same value for x. Does that make sense? So it really doesn't matter which one I use. Okay, let's pick the one that's the easiest. Do I want to pick this one? Not really. It's going to have a couple x's going on, right? We're going to have a quadratic because we're going to get x squared. How about this one? Would this one be okay? Yeah, what about this one? That's probably the easiest one, right? Okay, so it makes no difference which one you pick. I'm just going to cross multiply here. I'm going to get 3x plus 18. No. Yeah. Is equal to 42. 3x is equal to, what's 42 minus 18? 24. So x is equal to 8. All good? Okay. All right. So number, which one are we on now? 611. SAS. SAS. So side, angle, side, that means our angle has to be nestled between two sides that create it. All right. So if I want angles A and angle D, then I need to be looking at this length, AB and DE, and I need to be looking at AC and DE. Those have to be the ones that surround those angles. So if I have a set of congruent angles, and I know that the two sides surrounding it are proportional and have the same scale factor, then I know that those triangles are going to be similar. Not congruent, but similar. Okay? All right. So let's look at the next problem here. Which method would you choose to prove the two triangles are similar? If all I'm given are three sides, then I would want to use the side, 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 right? Okay? Couldn't use side, angle, side. I couldn't use angle, angle, angle. Okay? Uh-huh. Well, we probably should write similarity because then we have SSS for congruence, right? So we would want to probably say similarity. Yeah. Okay. All right, how about this one? You want to really pay attention to the letters as they are written out. All right, look at this next one. I'm saying XZW. XZW. So that's the left triangle, correct? And YZX. YZX. In other words, what's going to correspond if I've got, I'm going to call this one triangle 1 and this one triangle 2. In triangle 1, what is XZ going to be compared to? And XZ, what is it going to be compared to? Claire? YZ. XZ and YZ. So you've got to be careful in these problems now. Don't assume that they're going to be, the reflexive is what we're going to be using because we're talking about similarity, and sometimes my drawings aren't that good. All right, and then ZW, well, ZW is going to be compared to ZX. So ZW on the left one and ZX. So do you see how we're comparing two different things? We're not going to do base and base. Did y'all see that? All right. So I have, what are my options? Which one could I use? I've got a couple. Where would my angle be? I would have a right angle, don't I? So I could use SAS. I would have to say that XZ over YZ is equal to ZW over ZX because that angle is nestled in between those sides, yes? Do you see that? Okay, and then what would be the other one that I could use? Then I have angle, a right angle. Okay, and what would my second option be for that triangle? What do you think? Only 2 people know? Allison? Sure, why couldn't I use side, side, side? I've got 3 sides on one triangle and 3 sides on the other. I would need to say that xz over yz, zw over zx, and what's my last option? What's my last fraction that I would say? Anna? Anna? Natalie? Yeah, I've been doing that all day today, haven't I? I think I have. Sorry. Okay, does that make sense? I think that's it, isn't it? All right.